Hello, hello. Hi. Playing around with the Twitch moderation tools. Thanks, Kakalatang Joe. That does sound a bit extreme. I wonder where you would ever need that, you know? It's like, woo! I guess if you have like a lot of people, who knows? Um, okay, GB assembler alpha 4, right? Build. Okay. Let me sort a few things out first. Font, I need to change that again. Let's make 18. Whoa, it's always so big for the stream. Oh, there you go. There's a little sneak peek for the next YouTube video. It's called What is Assembly? The title is not final yet, but I'm currently writing the script for it, so just a little explanation of what an assembler is, or the assembly language. Oh, nice. I just got an email about the new contract for my rent. Yay! It's a 3-year contract, so I got extended. Whoop, whoop. So this background won't change anytime soon. Yeah, maybe those live event streams with 20k viewers, they probably need the shield mode or something like that, you're right. Not that we'll ever get to these numbers here in our humble abode. While just coding away on stuff, right? But hey, it's not about the views, is it? It's about, I don't know, the end product that we're getting out of this. Okay, so what have we done last time? Mostly I have been working on this keyword gen, right? That is able to create the keyword enum and all those static arrays and then add those entries directly to the hash map. You know, just out of this definition file. So whenever the hash map bucket size changes, or I need to add a new keyword, I do not need to fiddle with the code. I just write it in this editor file, in this definitions file, and then, you know, it will sort of generate itself, which is pretty cool. The usefulness of this is nice during early development, but then later on, those keywords probably won't ever change, right? So, you know, you could argue you could just have typed this out by hand and it would have been fine as well, instead of spending like a whole day. By a whole day, I mean, how long did we stream? 4 or 5 hours to make this tool. And, you know, 4 or 5 hours for something that's kind of crude. There's a lot of things that I should change about error handling and this sort of thing. But, you know, I wanted to do it regardless because it's a nice learning experience on how to do these things in C, right? How can you do something slightly static in C and write a code generator in a way. On that note, I'm using this Dani lib right here, which is like shared header files that I use everywhere throughout my project. So even like the GameBoy header extractor, for example, right? It has Dani lib included. Because those are like very common things that I figured out that I need and I'm using quite often. So this contains like all the type devs, right? Some macros like is true, is false. calculating kilobytes, megabytes, gigabytes, and terabytes to bytes, right? That's something you have to do quite often. It has asserts in here. It has an unused macro. It has a macro for array count, stringify, that sort of thing. Min, max, right? That's something you might need to do. Clamping of values to a ceiling or a floor. Is power of 2 or align something to the power of 2, right? That sort of thing. And then I have a file for the arenas here, right? Which is the memory arenas. So basically the virtual memory that gets allocated or rather reserved, right? So you want to reserve 2 gigabytes of memory, but not actually use it. So the operating system is still able to do something with those 2 gigabytes. And as your program runs and needs more memory, you just use more and more of that space and tell the operating system, hey, I kind of need that memory actually, you know. So, and that is something I use quite a lot as well because it simplifies memory management on the C and this kind of stuff. And occasionally when I do these projects, you know, some patterns emerge of things that I need quite often, right? For example, strings. Turns out I use them in every project. This exact header file, right? I'm just copying it around, this header file and the C file. So what I started doing was adding the Dani.string h for the Dani lib implementation, right? So this will contain all the string stuff that I'm using, and I've not verified that this works yet, so I kind of want to use that though. So I will be deleting these 2 files, and I will be using the Dani string.h thing instead, right? So that is one of the things I changed. Oh yeah, and that is pretty cool because this thing uses memcopy or, you know, VSN printf, right? Which is sort of like a common formatting thing. You might want to provide specific implementations for these. For example, what if someone doesn't want to use memcopy, right? Because it's not available, then you want to provide something else. You can just define it yourself, basically. You can just override this define and point to whatever else you want to use, right? For example, string VSN printf points to the STB headers, which is a third-party library. But if someone doesn't use it, they can just define, you know, do something like define this with printf, if they would like to, right? You could actually do something like this, I think. Obviously, this wouldn't be in this header file, right? This would be somewhere else in the code where you actually define it. But I mean, if you have the header files, you can also just go in here and change these, whatever, right? It doesn't really matter which way you do it, whichever is more comfortable to you. But yeah, so I'm doing this, and I started also doing like some tests. So I have some test cases of these headers because I was like, okay, it would actually be nice to verify whether all of this works or not, right? I mean, I know it works in the projects, but if I ever change something in here, I don't actually know if my change breaks something or not. So it would be nice to at least have like a little test. So I wrote like little test macros right here, which are able to run sort of like unit tests, although not as extensive, right? It just checks whether a statement is true or not. Let me actually show you. So we can go to see the projects, Dani lib, right? And we can say build and build run. And there you go. It's running the tests right here, right? It basically checks whether these conditions are true. I mean, these are fairly simple ones, right? And then it prints out okay or failed. And if it fails, you can see it down here. You can also have like test units, right? So this is running the test base function right here. And the nice part is this macro just prints out the test statements as a string, which is pretty cool. So you can actually directly see what it's testing and stuff. Anyways, I thought this was kind of cool. But yeah, so what I want to do is replace this string with this Dani string right here. because that is the official shared library that I'm going to use from now on for all my projects. I will do the same for the GameBoy header extractor and stuff like this. And, you know, this is how I sort of build my own version of a standard library, right? Of course, this only works on Windows at the moment because I'm not using any other operating systems at the moment, but you can imagine if I ever want to transform a project or do a project on a different operating system like Linux or Mac or whatever, I would go in here and, you know, would have to make these headers work essentially. But well, I'll see how to do that when I get to that point. Another thing that I want to transfer over to the GameBoy assembler build is I kind of got rid of the run and debug scripts and sort of combined them in the build script. Because most of the time I realized what I'm doing is I want to build and run. Right? There's rarely a point where I just want to run. And if I just want to run, why not just run the executable, right? I mean, it's not that difficult to cd into that project folder and run it, right? So, yeah. But basically, I extended this so I can now say build run to run the product, which will just simply call the build executable, or I can specify run dbg, which will run the specified debugger, in this instance rad debugger, right? And this should actually go somewhere else. So I run the debugger with the executable that I want to debug, and that will be release or, you know, release mode or debug mode, whatever. And rad debug is quite nice. I figured out it has this auto step command flag, which means it will automatically also step into the project while it opens rad debug. I can show you. So hang on, I have to go to the other folder again. So cd projects, Dani lib, right? So I can say either build, right, or build release, build debug. That still works. It builds the different versions of this, right? And then I can say build, release, run, right? So this will... Interesting. Oh, there's an error. Because, right, okay, cast truncates constant value. Interesting, okay. Forget about that. Let's just say build run, right? And then it will build the project. So it does the debug build here, and then it runs the application right after it, right? Or I can say build run debug. And then it opens the debugger and immediately starts, you know, stepping into the first line of code. And then I kind of step through my code already, which is kind of cool. And of course, it reduces files because, like, I no longer need this run script and this debug script. So actually, let me start with that, right? So let's remove... Whoa. Yeah, let's do delete file and ranbot delete file, right? And then we basically just copy these build changes that I did for my library into the assembler. So we have this. So we have libraries, right? Let's do it. No, actually... Yeah, this is fine. This is fine. Okay. So we have debugger, and then, you know what? Why am I doing this so complicated? Let's do this. Right? Wait, how does this work? Yo. Ah, right. Okay, so here what we want is Dani build.bat, and here what we want is GB assembler alpha 4 build.bat. Compare. There we go. You can actually figure out what's different, right? So this is fine. Okay, I added some disabled warnings. So far, I don't need it for the assembler, so I'm just going to leave that empty for now. But essentially, if we want to disable some warnings, we can add that in here. Sure, reload the file. Right. Yep, I just attached that to the compile thing at the end. There we go. Build a product. Okay, so this is compiling keyword gen, right? Which is using the disabled warnings as well, so this is okay. I think this can stay as is. Then we have no keyword gen, building without keyword gen, right? Or building exclusive with keyword gen, and then we run keyword gen. That is okay. And then down here, this is the new set where we run the product. So basically like this. All right. So now, well, no, I didn't want to start a new one. I wanted to go to this one. So build, run. There we go, and it runs the assembler. Nice. With all the glorious error messages. Yeah. Or build, run, debug, right? And voila. Can run it with a debugger. Dani base.h has been deleted. Okay, if you say so. Oh yeah, I moved them and I still had them open here. You know what? Let's just close all these tabs because this is getting a bit out of hand. Okay. So we changed that, and I have make keyword gen a bit nicer. I don't want to clean up today, though. I don't feel like cleaning up code. You know, like code cleanup is probably something I can do off stream because it's kind of boring, right? But I do need to extend it with the dictionary and stuff, although the dictionary is not really implemented yet. Oh yeah, one of the things I wanted for the dictionary, is to split up the dictionary into different sections. So at the moment, it's just a list of strings, right? So every single keyword and every symbol that you could ever possibly need is going to be in there, which is ridiculous, right? But we already know, based on how assembly works, right, that only a few things are ever allowed. For example, right after the label, we know whatever we type here is going to be, you know, an instruction. So we either need to check the dictionary for instructions or for user labels, because it could also be an alias, right? So we don't need to check for like, registers or anything like that. While we're in operands, we should also check for registers and things like that. Makes sense. But then when we are on labels, we don't need either of those, right? We don't need to check for registers or for instructions, because labels could only ever be like it depends. On label definition, I don't really need to do that, right? So, but you see where I'm going with this. So, kind of separating those would maybe make sense. But also not really something I want to do today. You know what? Let's add all the keywords, shall we? That is probably a good start for today. Let's close this. And then I have GameBoy instructions. But that is kind of all the instructions. Let me open up the old project, because this is a rewrite, so we have an old project actually available. And just copy keywords from here. So here we are, keywords. Choop. Yep. Cool. And then we need all of this. Yeah. Okay, so data and alias are assembler directives, which means these keywords interact with the functionality of the assembler directly. They have nothing to do with the GameBoy CPU or an instruction or anything like that, right? So let's remove those for now and try and get some order into these things. So I think those are instructions. Nop, ink, deck, yep, this, hold, add, whatever. And these are directives and stuff. Not directives, what you call them? Come on, brain. Registers and things like that. So, okay, let's put the registers down here. Give them sort of a lower integer value, right? And that reminds me, it would be nice to have comments in this file. So maybe we do work a little bit on the keygen. It would be nice to have comments in here. So I can remove some of them for now. Yeah, okay, let's add comments. Definition, token type, comment, right? And then we check the code point. And let's just plug it right here after the white space. So else if code point is, let's do like the assembler, assembler comments are with this one, with a semicolon. So token type comment. There we go. And then we need to find the end of the comment. Which is basically going to be the end of the line. So we can actually copy something that I've done for the parser itself, right? Read end of line. There we go. Why reinvent the wheel when you already have written this function? Okay. Let's call it keyword gen read end of file. End of line, I mean. We have the source file, the code point. We get the code point right here. We check if it's end of file or if it is not a new line, and then we swallow. Okay. And then we have a new line token right here. Cool. So file. There we go. Now we have comments in our file. That means whatever we have not implemented, we can just comment out, right? Whoa. Shoot. I don't have multi-line comments, so I shouldn't have that many comments anyways. Okay. So this will be registers and other flags. Is it flags? And conditions. Conditions. There we go. Instructions. We can also split up instructions, right? So, oh yeah, and there was a really annoying bug. Let's actually do that one. So let's do no op, right? No, like this. So the bug was, oh, I need to put this at the end of the file in order to show you this. So if we then go build, right? Error, invalid token, right? What? What do you mean invalid? What? How can you be an invalid token? Line 1, column 1. That's the very first character. That's the comment I just added. What do you mean invalid token? Oh, because I don't handle it happy. Yeah. Case definition comments. There we go. Okay. There we go. So the actual error is this one: missing new line after keyword definition. Right? That should not be necessary. So it says read expected new line, but I mean, we check if it is a white space to skip it, right? If it is not a new line, and token type is not definition end of file, right? Build. There we go. So now it works. It just says running keyword gen and that's it. So the issue was we always want a new line, but if we are at the end of the file, then we don't necessarily care whether there is a new line or not, right? So we just simply check, hey, If you are not a new line and you are not end of file, then this is an error. But if you are at the end of the file and you're not a new line right here, then who cares, right? It is the last definition in the file, so we don't really care. That was just something that annoyed me. It's not necessarily bad. I always leave a new line at the end, out of habit, but it should work regardless, right? Okay, so now we have no op. So if we build this keywords, there we go. Keyword type no op. Right, it's right here. Okay, then let's make sure our parser actually recognizes keywords. How do I want to do this? Oh, I had the keywords right here. We no longer need this one. Now have a label definition, right? Or yeah, that is all right. Insert label definition. Oh, so does this still work? You know, if I have a label called nop, will it work? Build run. Apparently it does work, but it shouldn't. Oh, hang on, right. I'm never calling this anywhere. Right. Oh, and the definition should also go in the header file. Okay. So we have still a little bit of work to do. So this... Actually, you know what? Let's keep the dictionary out of it for now. Because we're not using it at the moment. And then... So this needs to be written into the header. Right, end of header file. There we go. I mean, it's a long string, but who cares, right? It's just a generation thing. Declared formal parameter list different from definition. Is that so? Right, because this gets generated as well, doi. And I need to remove the dictionary in there. Where are you? There you are. Goodbye. There we go. Arena unreferenced formal parameter. I mean, that is true. Yeah, I don't really need the arena here at all, right? I'm just assigning things. So I think I just pasted it out because, for the dictionary stuff, but I really don't need this. Okay, so arena gone. And also here, gone. We just need the hash map. And then I want another space in here. Okay, and then I can call this one. Where would I call it? I think I'll just call it in global symbols table. Right? So I can just say G symbols table and fill it with keywords. Okay, but symbol C needs to know includes keyword gen keywords.h. Right, because we're parsing. What do you mean you don't know it? It's right here. And you're using keywords.h, which defines it right here. Oh, yeah, this is where this bites me in the ass, and I have that in the to-do. Remove some of the includes, because I'm also including the whole symbols table file in the keyword gen, which is absolutely not necessary. Okay, let's clean that up. Let's just remove some of this shiz and see what we can keep and what we can't keep, right? We don't need stats. I think all of this we need. Do we need token? I don't think we need token. Okay. Let's see what we get. Okay, init global dictionary. Well, we're not using dictionaries right now, so screw that. Init global symbols table. Well, we also don't need that because we can just have a hash map, right? G symbols table, we're just going to change into hash map. So really, we just need this part right here. Right, and let's just call it symbols table. Actually, that's it, right? Yeah. Okay. And then hash map t. Symbol table bucket count. Right. Okay. So we do want to use the same bucket count always as the program. Those should not differ, right? So it would be nice to just have one defined that I can refer to. Might as well just add it into hash map. Yeah, hash map default capacity, right? So then we can change that here. And we can change that in symbol C line 9. Cool. Now they use the same bucket count. And we just successfully removed all these headers. Yay! Streamlining our program. Fantastic. Okay, so build run. Error. Labels cannot have the same name as keywords. Nop. Nice. Okay, so this error now works again. Fantastic. So now we want to recognize nop in our parser. Right, so we have label recognition. That is fine and dandy. We can probably streamline that a little bit. How did it have an invalid token error before when I... Oh no, that was in the keygen. Never mind. So build... no, build run. Ah, right. That's why I disabled it, because the test file at the moment recognizes all kinds of stuff. Okay, let's leave it commented out. So, okay, let me just add another case. This one will be for token type identifier, because that is what we're having, right? So, what do we want to do? Well, if token... Okay, so here I wanted to check the token length. I do not need to do that for identifiers, because if there's no characters, then we will never report an identifier, right? An identifier always needs at least one character. The reason why labels could be a token length of 0 is because the label has the colon at the end, but does not report it in the length, in the total length, right? We just leave it out. So therefore, we don't need to do that stuff. That is cool. But now if we have an identifier, we want to kind of check what kind of identifier this is, right? And since it's not a new definition or anything, we're not trying to insert it into anything. We just want to check our symbols table whether it is there or not. Right? So that means what do we actually want to get returned? This symbol thing, right? So let's make it this. Get symbol from... Well, I do have the tokenizer passed in. I don't know if I actually need that or not. So maybe let's not do this in the header. Let's do this right here. And just copy this one for now. Right? And this should be a symbol pointer. Oh, I never checked tokenizer. Tokenizer is not null. Just copy this. Okay, we don't have an insert result. Do we want to create a string copy of the identifier? Well, it all depends on what we're going to do with the identifier, right? Why did I do it this way? I forgot to turn off notification on the other machine. Hang on. Do not disturb. So the tokenizer is just used for the file in the arena. And then the token itself really just for line, column, and position and this kind of stuff. So I could have the file name actually in the token as well. So I don't need to carry around the tokenizer, and I can just pass in the arena instead of using the tokenizer arena. Because maybe I don't want to use the tokenizer arena, right? It might be a different arena because this is the parser after all. Why is the tokenizer holding on to the arena anyways? There's no reason for it. And then this token is the current token of the tokenizer. So it makes no sense that I pass in the token separately because it's just current token. Let's rename this to insert current label definition to make it more clear that we're talking about the current token. And then let's just remove this and only pass in the tokenizer, right? We can check for the type actually. Token type label definition, right? Oh no, I just called this label. Damn. Okay. So, and token only used down here. So we might as well do it this way. So token equals tokenizer current token, and we need the address of it. Right. Okay. And then here on symbol, we want to make sure that the current token is an identifier. And then we can do the same thing of getting the current token like so. But here's the thing. We do not need it to be a copy yet. Right? Because we're actually trying to get something out of the dictionary. We don't try to add it. We're just trying to get a symbol. And then only after we verify that the symbol doesn't exist, we might want to add it as an unresolved symbol. Now we have to kind of think about how do we deal with unresolved symbols. And when do we resolve them? So, we have a global arena, right? What do we add in there? Well, every temp allocation, whoa, every string copy, right? Every dictionary and oh my god, stop saving the file. I have it so ingrained that I press Control S all the time. So we have the hash map buckets. We have the symbols. We have label definitions in here, right? Basically everything at the moment. What we might want to have is a separate arena, right? So my problem is unresolved symbols, right? So unresolved symbols need data such as the file name, right? So where is this unresolved symbol? We need the line, the column for potential error reporting, and the byte position, right? Of where in the file it is, so we can make a string out of this, right? Or we have a string copy of it anyways at some point, but doesn't matter. So this is what an unresolved symbol needs. It also needs the offset in the binary file, so in the output file, so we know once the symbol is resolved, where in the output file we should write whatever is resolved to, right? And we can't have a fixed size array because we don't know how many symbols a user might define, right? It can't be a lot. So what we're going to do is we point to the next unresolved symbol right here, and we also have the first unresolved symbol, right? Oh my god. So a singly linked list, basically. Now, if you add it into the arena, right, you might have something like unresolved, unresolved, some other memory, right? Then you have another unresolved file. Then you might have some more memory, right? Whatever is in there, could be actual symbols or whatever, unresolved again, right? So that would be like the memory layout. So let's say we start with memory, right? So there's a bunch of unresolved symbols dispersed out through the arena, right? And now once we start resolving them, so let's say, for example, these two are now resolved because we know we finally found the label definition of it, so we can actually resolve this. We then need to figure out how to deal with the memory, right? Because we cannot just remove this. We would have a gap in here, which essentially turns out to be empty, which of course is wasted space. And now let's say we have a new unresolved symbol right here, right? We would attach it to the end of the arena. This means we would have entire chunks empty. So what I'm thinking, maybe we could have something like an empty unresolved slots, right? Which basically has first slot, next slot. Whoa. This now would point to this element. And with this unresolved slot, so once we get a new unresolved symbol, we can then figure out, hey, do we have any free slots? Instead of adding a new unresolved symbol at the end, let's just put it in this slot, right? But here's the issue then. It only points to the next element. So we have unresolved, which points to this, and this would then point backwards. I don't really like that. I was trying to think whether that will be a problem or not. Because really, unresolved symbols, so let's say an unresolved symbol from foo doesn't need to point to an unresolved symbol from bar to bar, right? Because we could actually put these already in the hash map. And then we just have a string of foos and bars, right? No, there's still this issue then. So if we resolve bar first, then that would be the layout. And then, another spammer, hooray! I wonder who thinks these things work, honestly. It's okay, I blocked him, I think. Yeah, it disappeared. I just figured out the messages don't disappear in OBS, but they do disappear in the other channel. This mod view is ass. I'll take your word for it. I don't know. I just double clicked on the name and selected block and then reported him for spam, but I don't know if that was the right thing to do. Sorry. What pop-up do you mean, by the way? Or is this like a mod specific thing? I don't know. Doesn't matter. I don't know what I'm doing really. Oh, the YouTube link. So the pinned message. Can't you hide that one in the mod view? I mean, you should be able to. Oh, maybe I can... No, I can only hide it for me. Sorry. Ah, it's alright. If it's over the message, at least no one sees it. So it's fine. It's fine. It's fine. Okay, back to this. So yeah, I'm not sure how I would keep them in sequence, right? So let's make this XYZ, right? So at the moment, if the unresolved slots would go this, then it points to this one, and this one, right? Now you suddenly resolve XYZ, right? Then this new one right here would be in this memory location, but this one would point over here. So now, and if you have all these jumps backwards and stuff, you kind of screw yourself a little bit with like caching and things like that. But then I wonder if it would be that much of an issue depending on the unresolved symbols. You could give them like an index, right? So the reason why I can't just compare the pointer addresses is because depending on the arena size, right, at some point the arena might be full and then we're allocating a whole new arena, and it's not really guaranteed that the address is after the previous arena. It might actually be for. Like, there's no guarantee, right? So if I want them to be kind of in sequence, I would need to have some kind of ID. That might not be a bad idea. Let me just check this blog right here from Ryan Fleur with the arena allocator, which is sort of where I got the idea from after reading that. And I think he described something similar. Yeah, first free entity. So what he suggests is pushing it at the front. So this would be the very first one. But I don't like that approach either. I think I might just add a small ID. Yeah. Yep. Okay. And then all the way at the end. Oh, but I kind of. Well, that is annoying. I'm just thinking all the way at the end what would happen if there's still unresolved symbols. Right? How would we find out? We either have to go through all the buckets and all the symbols in the symbols table to then check for unresolved ones. Or we have that be a separate list as well. Oh, dear Lord. Well, okay, I need to think about this a little bit more, but essentially, I don't think this is of concern right now, anyways, because in this stage, we're basically at the top level, right? So this is the very first identifier in this file. Either we have label definitions or we don't. And if we have label definitions, it's fine. We just continue with all the label definitions because we can have multiple label definitions, right? So this is essentially valid. A, B, C, D, E, F, right? And then we can have an instruction. So this is valid code. Ah, right. Hang on, let me quickly make it build. What? Ah. Right. Yeah, so the first error is at line 13, which means line 12 just passed just fine, right? And so this is all correct. Now, if we would have another label here, that will be an error, but this is one stage deeper into the state machine, right? So the first unidentifier we are getting here, we're expecting it to be an instruction. An instruction or a directive, though directives are not implemented yet, but it's one of those things, right? Although directives won't be an identifier, so let's scratch that. It's just going to be identifier. I mean, the identifier could be an alias, right? So we could have this in here, because potentially we could have an alias for LD, which we name load, right? Something like this. Or let's go with not, because this is the one I have implemented, right? So no operation. So if someone doesn't want to write nop, right, and they want to be more descriptive, they could write no operation instead, which we then would have to resolve into a nop, right? But I'm not sure if I want to allow aliases for instructions yet, but so anyways, what I'm saying is in this position right here, we're always expecting this to be an instruction, right? This should be an instruction. So really what I want to do is just get a keyword. Nah, but a more global get symbol is fine. Okay. Anyways, let's implement this and then worry about all this other stuff later. Get current symbol is the tokenizer, right? It's a token type identifier, right? And so token is current token. We do not need to do the copy. Let's just do a string, because we're just trying to read it, right? So strt identifier. Then we have hashmap get value in the global symbols table, which we should probably check that it's not null. Hashmap get value, right? Identifier, and then we just get the pointer. Okay, that is fine. Okay, item. It would always be an item. If the item is not null. Well, it doesn't really matter, does it? You just always return this. And none of this is needed. Okay. Okay, so in parser we can say get current symbol from tokenizer, and this will be symbol t. Symbol, right? If symbol is null, then this is an error. You know what? Having this like in a separate function right now is just bonkers. This kind of made sense because it's a lot of code, but I'll do it the same way as I did with the insert current label definition. I won't make it a separate function. I just plonk it in like that and see what kind of pattern emerges, if any. Right? So add token error. What do you do? It calls add error and add error. Does it immediately do the formatting? It does. Okay. So that means this is okay if it's not a copy. I'm skeptical about get hash map value. Hang on. This can actually return null. Why can't this return null? It actually can. I don't like this whole symbol.h file, honestly. I don't like it. I'm starting to overthink stuff. But the reason why I'm overthinking is I do not want to end up in the same mess as I had before, right? Because, like, that's why I'm doing the rewrite, right? Because I do not like what I had before. And I kind of want to make it a bit nicer. But here we are again. Yeah, can close this one. And now I'm wondering if keywords should be in a separate hash table altogether. And then have a keyword token. And then we can fine tune that hash map. So that would also kind of simplify this kind of code, right? Because I don't necessarily need to hold like this whole symbol type kind of nonsense. And that way the symbol table is really just for user-defined symbols, which makes it easier to iterate through and then figure out, what kind of symbols are still unresolved and this kind of stuff. So maybe I do that. Have two different hash maps. And this would just be an int, essentially. Well, not quite. But that could also mean I could put some order into the keywords itself. So I could actually sort these based on different types, right? So have registers and actual instructions. And I could have jump instructions separately. I don't know if that will be useful, but okay, I'll make a separate hash map for keywords. Fuck it. And add a keyword token. That will make things a little bit easier, I think. Not easier, but it like structures the code a bit nicer, I think. Yeah. I decided. No turning back. Don't overthink it, just do it. Okay, so that means keyword type enum. Okay, let's think about a new type, right? So we have a struct keyword, right? What do we want in there? Well, we want a type, right? And the actual value, basically. So type is either register or whatever, right? Or instruction. I wonder if a keyword now actually could also be a directive, which would be kind of cool. Yeah, so we need keyword type enum now slightly becomes something else, right? Actually, this will be keyword type. It is the actual type of the keyword, so it either is an instruction or it will be a register, right? And later on we can think if we also want directives like this. Right. So this will be keyword type. And then we have this actual thing with the keywords. So we have... No, but then I need to figure out what value is and whatever. Nah, this is... No, okay, this is overcomplicating it. Yeah, it's just going to be keyword type. That's it. Same as before. Okay. Means I don't need to change too much of the thing. The only thing that's going to be different is we no longer need symbol. Because that will just be keyword type value. So we have the entry and the value. And this will just point to keyword data dot value. Right? And the value will just be the keyword type, like so. And then this should be memory arena T arena. And the code itself right will be this. And let's make it a global keyword table. Right, we want the capacity. So there's one thing I'm going to add, which is the buckets. So what we're going to do is, let's say, no, we're going to specify that in here. Let's make it 10 buckets. Nah, 10 buckets is too little. Let's make 64 for now. I mean, how many thingies do we have? This is 43. 6. Yeah, okay. 60 basically. 61. And this will go right. We'll just write the exact value in here. Okay, that will initialize the keyword table. If this is null, write last Windows error and exit. Fail to create global keyword table. And then we have global keyword table base yada yada. Dot entry is global keyword data. Keyword type nop, and then the entry. Okay, so that is the code I want. This file doesn't need to change. So, keyword gen. Create header file. So, do we need to change anything here? No, this is still fine. This is still fine. We have the type diff enum of keyword type. No, this is still exactly the same. Okay, but this definition has changed, right? So this goes into the end of the header. Right, so this changed. Okay. And then keywords.c, right? So create source file, yada, 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 and type of struct, keyword data, yep. And then we have the actual keyword data, which is the hash map entry. But instead of symbols, we have this value right here. Okay, keyword data, still the same. Okay, write source file. Keyword data dot entry. Yes, this is still the same. Then we have entry item value dot value, and then this is dot value, which just becomes the actual keyword. Like so. I made this little macro called string to format arguments, which is kind of neat. Essentially what this is doing, it is just taking the string and then writing out string.length, comma, string to C string, which is basically using the base. So I don't have to type that out by myself. So if I have an identifier like this, keyword enum, right, and I used fixed length one because those are not necessarily zero terminated strings. So I want to specify the length, and I never want to write out length and then base or whatever. So this macro is kind of an easy way out for that. Okay, and then right. So this is the middle part. Create source file. Yep. Okay, here, hashmap base. This will be g keyword table base dot entry keyword data blah 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 dot entry. Okay, so this is still the same. And then end of the source file. Okay, so this is the actual method. Now we need to write a little bit more stuff this time. So we need to write this. And some more output strings. So let's do that. Right. We want this followed by this line. Except this one, LLU, right? This needs to be a format. And this will be right, I need to format it. Okay. New hashmap code, string format. We want an arena, right? Do I just have an arena here? I should. I mean, yeah. And this will be the format. Right. And then we want why did I close it? Jeez. Right, keyword capacity. And then we want this code. String literal. Okay. Up. And this one. Up. Except we need to quote these. Right. Let's do this one and then /n. And then we have the setup lines, where we write out all the setup lines. And then this. Okay, so this should be correct. Famous last words. So, no, it's fine. Keyword C. Okay, let's delete those. What? So keyword gen, we have our definitions. At the moment, it's just no op, which is fine. Build. Okay, syntax error. Why? Because what are you on about? What do you want? String format. Arena, comma. All this shiz, comma. Keyword, table, oh, did I accidentally put a semicolon? Yeah, I did. Okay. Okay, so it generated the code. This seems to be fine, but here, I mean, I know this is fairly unreadable because I didn't do any tabs or anything like that, right? But the entry seems to be correct. But I have not added the static. So in here we need static hash map t pointer global keyword table equals 0, right? So let's write that into the file. Let's delete it. And where is the source file beginning? Where I write the here. Yeah, it should be fine. Init keywords must return a value. Well, that would be correct, wouldn't it? No, it doesn't need to. Right. Okay, let's change that and also change the name slightly. Let's call this. So first of all, it is void init global keywords, right? Why is there an? No, that should be /nn, right? And then in the header file, is it at the end of the header file? It is this one. Should be void init global keywords. Okay. Right. And now I have symbols, which no longer works, right? Because I had this thing in here, which I don't want to do anymore. That is fine. What I want instead is here to say init global keywords. Cool. Okay, and now I can add the keyword token, right? So instead of identifier, let's have token type keyword. Okay, and that means in token, let me just check the yeah. Okay, here I want to include keyword gen keyword.h keywords.h. And then when we are down here with the identifier, where we read the end of the token, right? Then we try to figure out if this thing is a label or not. If it is a label, we'll kind of make it a label, right? So if it has a colon at the end. But before that happens, I also need to make sure. Well, do I already check for a keyword or not? So this depends now. I'm thinking about the error handling, right? So we could have a situation where we have a keyword, like, for example, nop, which is fine. That is legal, right? But we also could have nop as a label. So there's two ways to do this. You either read this as a keyword token and then have an empty label, but that would be kind of weird, right? Because then you would have like whatever this keyword is, for example, LD, and then you would have, oh, invalid token for LD because an operator is expected, right? Which is kind of awkward. Because I kind of like the error message that I have right now where it says, oh, you can't have labels with the same name as a keyword, right? So what do I return? What do I do? Because I do not want to stop parsing when that happens, obviously, so I still want to continue. But do I report an invalid token? And just ignore it? Like, because the error gets added here anyways, as opposed to in the parsing, where error handling at the moment happens. Let's see what that would look like. So let's try and figure out if this is a keyword, right? Wait, what did I name this? Keyword table. Okay. So we just need hash map get value. Right, with G keyword table and a string which will be string from token No, I need this. Okay. So this will be file base file position and file position minus token position. That will be the identifier, right? And this is a non-copy one, so this will be pointing directly into the file, right? So it's not zero terminated, but that is fine. Our stuff can handle that. And then we just look for the identifier here, right? Figure out if it actually is in there. And if it is, then a value will just be the keyword. So keyword type T, keyword equals whatever item value, whatever this one is pointing to. Oh, but I don't have any way of carrying values for tokens. Oh, that is annoying. So I want to have number parsing in there in the tokens as well, and it would be nice if I can automatically parse them, but then so these do not need values. These might. Yeah, I'm not sure about these. Okay. Why not? And then here for the token, where's the tokenizer code? Here, tokenizer. We already have read token here. Okay, so token value equals 0. Right. If I do this, I probably don't need the length. If I'm actually starting to return values with the tokens. So these I still need for like error reporting, right? But the length might be unnecessary down here. Because I can now just start returning the value. Then I don't need this awkward length modifier shit that I did here for the labels. Yeah. Okay. Cool. Yeah. Let's remove the length. Okay, so we have the identifier. We figure out whether it is a keyword or not. If it is a keyword, we want token value to just be item value. Done. And we never need to create a copy of that string. Okay. So now what about labels, right? So we probably want to check whether this is a label or not. So we're doing this, figuring out whether it has a label thing attached to it. Let's just do that. That is fairly cheap to do. Okay, but that is besides the point of what I wanted to do here. Okay, so if it is a label, let's call this keyword instead, right? Checking for a keyword, we're getting the keyword value. Oh my god, if keyword is not null, then we want to report an error for invalid label names. I'm just trying to figure out how to handle the parsing code now then, because I could return a label token. But that doesn't make any sense, right? Because then I return the label token, then we'll try to add this keyword to the label, which is not allowed because, like, you know. Actually, I'm wondering, in all seriousness, so what? Why can't I have a label LD? Ah, because of that. So I could either now create like an invalid token type that I can return, which then the parser can just ignore, right? Because we already reported an error. So whenever we get like an invalid token, we just jump over it. That will be one way to do it. The other way to do it would be to let retoken call itself. Or what I mean by that is like we have tokenizer advance, right? Where we basically call retoken to fetch the next token. But what if we already check whether this is invalid and then just loop over until we get a valid token, basically ignore all of them. But then you kind of end up in a weird... Nah, I can't do that. Let's try the invalid approach, right? Let's say... At least you know where it happened and you kind of know, okay, this is a label. No, do you know it's a label? No, you don't. No, I handle that on the outside. Why am I even overcomplicating this, right? Read the freaking token. Check if there's a label afterwards, right? If there is a label afterwards, we report this as a label. We swallow the cone point. And now we want the label name, right? So we have this identifier right here, which at the moment is not a copy, which is perfectly fine. So we can say I have token text. Token text, right? Just do it this way. we do this. We don't need the texts for any of these. Here we have the identifier. If we have a label, then it is most likely a new label definition, right? So we want a copy of this. So what we can say is token text equals copy string. Hey, thanks for the follow. And the string copy right needs an arena, so we're gonna do, what are we gonna do? Do we have an arena? We do not have an arena, right? Because I didn't want this to allocate. Right. Then maybe we shouldn't. So really then, let's make this. Right. Okay. Then, if it is not a label, then try and get the keyword out of the keyword table, right? We're using token text for this one. Let me close this shit. And if keyword is not null, then we set the value to this value, which is perfectly fine because it's basically additional data. And if it is null, then we have a token type of identifier right here. So this one goes up here. And this one will be token type keyword. Okay. Okay. Oh, hang on. I have token position. But that is before this one. Okay. No. That's the beginning. And I'm not touching those inside. So really, this should be token position. And this should be the other way around. No, this is correct. File position and token position. Okay, yeah. Okay, so then text. Let's see. I mean, I could let text always point to the text that it read out of the file, right? Instead of having it like this. That probably makes more sense. So I could say text.base is always gonna be file base file position, right? And then I just have to adjust text.length. So really, I should have kept it. I should have kept the code from before. Shoot. Okay. Token. No, actually, you know, let's just always assume a length of 1. No. Length of 0 maybe. And then only if I have something that actually does need a value, I'm gonna adjust the length to that. So down here, really, I just want length. It's gonna be this, right? Okay, now for strings, I can probably do the same thing, right? So strings read up to the end of this. So I want the quotation marks included in the string to then verify it later on. So really, this one needs to be the same. Read the end of the string, and then that will be the text length, right? Directive, I don't know yet. So this is an empty label, which means the length will be null. So that is perfectly acceptable. And then we have numbers, and numbers, we're just going to put the length until the end of the parsing. And everything else will just have a length of 0, because we don't care about the actual values. Oh, no, we do care here. Right, because this is a number. and white space sequence and stuff like that, we actually do not care. Is this actually used anywhere? Oh, in the invalid token stuff. Okay, let's remove that one. Don't need it. Go away. Okay. So now, in parser case, we can actually check for keywords. Hooray! Right, and if we have a keyword, we probably want to check the keyword value, right? So that will be keyword T. You know what? Let's make a separate function for that already because I know this will be huge. So parse keyword, right? Tokenizer. Huzzah. And we just call parse keyword tokenizer. But you know what? I don't really like the loop makeup right now. Let's say parse current keyword. Okay, let's make an assert. Tokenizer is not null. And we assume that tokenizer current token type is token type keyword. If it is not in debug mode, then it will throw. The debugger will step in, let's put it this way. Okay, and then we just want to do a switch. Yeah, we want to do a switch over no, let's get the keyword value. Keyword type T. Keyword, right? And that will be tokenizer current token value, and that will be keyword type T, right? And just want this. And then we can say switch keyword. And then we can switch over all the currently supported keywords, right? So keyword type NOP, for example. That is the only one we have right now, right? Yep. And we do whatever nop needs to do. And, well, at the moment we just ignore it, I guess. Otherwise, we can report, I don't know, add token error. What does add token error do again? It gets the file name and the current token stuff, and then I can add a text. Right. Yeah. The tokenizer, and we want, what do we want to say? Unsupported keyword dot this s, and that would be tokenizer current token text. Did I use this macro? No, it's only in here. Let's move you to string.h. How about that? And then I can use it here as well. Okay, this is the only case at the moment, right? Because I don't have anything implemented, but at least it would recognize all the keywords and then just say, well, this one is unsupported, mate, what are you doing? Right? Or actually, maybe I should not say parse current keyword. What I should say is parse instruction, right? Because that's essentially what it is. Okay, here I have to add like something else as well. So the token text.length, right? This just means an empty label definition is not allowed, but now I also need to check whether it is a keyword or not, right? So for that, I basically have to do the same thing as in the token. So, right, this one. And we're checking for a keyword in the keyword table, token text. If keyword is not null, then we can add the error right here. Labels cannot have the same name as keywords. And we have this one. String to format args, and that will be token text. Right. Symbol type keyword no longer needed. So, goodbye. This needs to create the string copy, which is right, but this should be... No, it's copy string, and that will be token text. Okay. And then token type identifier. That really at the moment is a completely invalid thing, right? So basically, at the moment we just ignore that error, but okay, builds. Token.c error. Okay, what did I screw up? What? Did I not copy? Okay, 8.3. What's this? Right, I need to get the address completely right. From U64 to U32, possible loss of data. Oh no. Okay, line 99. Oh, because of length. Oh, fantastic. Fantastic, fantastic. Okay. Basically, tokenizer should stop parsing if strmux is reached. Right. Whoops. G keyword table. Unrecognized modifier. Why would that be? Because keywords comes after this. This is no longer referencing symbols or anything, right? So really, you can go up before parsing. Symbol type keyword unrecognized in parser. Oh yes, of course, because this is token type, not symbol type. Okay. So. Empty label definition not allowed, line 15. Correct, cool, this works. Line 16, empty label definition not allowed. Yep, cool. Line 3, 4. Label entry point is already defined on line 14. Entry point, correct. But this seems to work. Which, why? Why does it work? Nah. Okay. Run debug. Okay, so let's go to parse source file. And let's go here. Oh, right. Hang on. There we go. Okay, so. Right. So this is fine. This is pointing into the A, right? So let's continue. B, C, D, E, F. Then we have no op. No op is here. Oh, come on. There. Okay, now we have no op. Okay. G keyword table. Oh. Right. So on the hash map, I have a little thing that says if the entry count is 0, just return null because there's nothing in this hash map. Well, guess what my generation code did not update? The freaking entry count. Oops. Wait, why are you so large? How can you be in position 402 if we only have 64 buckets? What's going on here? What? Okay, there seems to be some more things wrong in my generation code. Okay, so basically what I need in the end here is to say G keyword table count is a count entry count, right? Entry count equals however many items we got. Right. So that needs to be going in. And what else? What else did I say? All right, this is not correct. So the position calculation is wrong. Probably because I'm using index. No, index is correct here. Bucket, 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 bucket. How do I calculate bucket? Ah. Right. I'm using the default capacity here, which is wrong. Keyword table capacity. There, I want this one. This one. So, this one. And symbols table really should be renamed to keyword table. Okay. Actually, build run. Right, I need the count still. Okay, how do I do that? Well, U64 count is 0. Count plus plus. And then G keyword table entry count equals percentage LLU. And that needs to be in a format. So strt entry count line, right? String format. We need the arena. We have the format string, and then we want count. And then we just write out entry count line. Um. What? Wait. That was a keyword gen. Oh. There we go. Okay, line 12, unsupported instruction no op. That is because we use indeed a no op in here. Cool, so this is being recognized now. And then we have labels cannot have the same name as keywords. No op. Excellent. Line 13. Fantastic. Cool. So this works. I love these error messages. It's the best error messages I've ever seen. Not really, but you know, I like to think so. Okay, cool. Now we can probably just do this. Actually, do I want to allow all instructions right now? Sure. No, you know what? I enable them one after the other. So labels should work as well, right? We have label definitions. That's cool and all. Everything else gets ignored. I mean, if I mean, there's lots of errors if I enable this one again, right? So unrecognized tokens. Oh, right, I removed that function, so I can't really do that right now anyways. Okay, that's fine. I mean, I have this as a to-do here, add all the keywords to the keyword gen definition file, but I don't know if I want to do that yet. Really what we need right now is the output file, right? Because a lot of the things now depend on the output file that happen in the parser. Because essentially we go over the tokens, right, figure out what kind of instruction I have, and then I need to write it into the output file. And the output file needs to keep track of the current position we have written to. Yeah. So let's add that. IO, let's say, what is that going to be? Just copy this. This is going to be the ROM file that we're creating. Right. So romfile.h and romfile.c. Include romfile.h and include io rumfile.c. Okay, let's close this one. So let's just copy everything from the source file for now and adjust. So rum file, tom file, yeah, sure. Rum file. Still have a file name, that is okay. We have a file handle. We probably won't use file mapping at all. Really, we don't even want to hold on to a file handle, to be honest, the whole time. Come to think of it, we just want an array that we like hold on to. And we can just use an arena for that and just call it the output arena, right? Which will then grow depending on what we need. Let's just call this the binary or the output binary. Output binary sounds okay. We need a memory arena. Now we don't need these for now. Let's just create this struct right here. Right. Assert that the arena is not null. Although, nah, we actually don't need to do that because the arena functions themselves will do that. All we need is an output binary, and we call get memory arena struct arena and output binary. There we go. And then just return the result. At the moment we don't do anything really, but we might want to do stuff, right? So what do we need? At first, I need 32 kibs of ROM space, right? Because this is the minimum ROM size for a Game Boy ROM, 32 kilobytes. And then once this reaches the end, you might want to increase the ROM size, right, as you build your ROM file. So first, you want to hold on to a 32 kilobyte buffer from the memory arena. But so this depends on how I want to structure my assembler, right? Because there's also banking involved, right? So you can have up to 8 megabytes is, I think, the largest chip that has been released so far. You could probably create a bigger one if you wanted to, but I'm not sure I'm going to support that with this assembler, right? So let's say 8 megabytes is the maximum at the moment. And you have basically bank switching arenas within the 32 kilobytes, which means you have, so the first 16 kilobytes are basically bank 0 and will always be the same, right? And then the bottom half, you can switch from bank 1 to n, right? And this is how you get to a maximum size of 8 megabytes. Now, in the assembly language, I probably want to specify which bank I am in. So I could say section bank 0, right? And then have end section, and then just have all the code in here, right? Whoop. Okay, thank you, auto generation. And then you basically have multiple sections, right? You at one point have section, this one right here for bank 1. Then you have maybe one for bank 2. And then there is also the issue of like labels. So bank 0 is the default section, right? And you can jump from any bank to bank 0 because bank 0 will always be there. However, you cannot have a label in bank 2, right? So for example, we have foo here and we want to jump to foo, right? That won't work because bank 1 and bank 2 are never at the same time in memory. So we kind of want to have an error in the assembler where we then say, hey, this code is absolutely invalid because this is like, it cannot happen. It physically doesn't work that way. Instead, what you want to do is probably jump over to something here. Let's call it Gaga, right? You want to then use the instruction for whatever the bank switching is. I think it's just something that you need to write into a certain register or something. Doesn't matter, right? So you do a bank switch to 1, and then you can use jump to foo from here, right? Because now you switched bank 1 with bank 2. So really, I probably just want 16 kilobyte buffers. So we can kind of make that our output structure, right? So let's say struct section, right? Binary section or whatever you want to call it, doesn't really matter. And those have a fixed size. We can have a base. We can have U64, which would be the size, and we have a U64 for the position. My dog is trying to get my attention. I think she might want to go out. How long have I been streaming? 3 hours. Okay, 30 more minutes. How about that? Can you wait 30 more minutes? Something like that? Yeah. Then I'll go out with you, I promise. Okay. Okay, we have one binary section which will be bank 0, right? Bank 0 will always be there, and so will be bank 1, right? But then this might be multiple banks, right? And then as you grow, you need to reserve more banks. And I mean, if we use a separate arena for that, that is easy peasy, right? Because we can just have them in continuous memory. But if we just want to use one arena that just grows dynamically with all the other data in there, just to keep it simple for now, then we might have to link those kind of together, right? We need to figure out where the next bank in memory is. So really, I mean, it's kind of a linked list again, isn't it? So really, let's say we have first, right, which will always be bank 0. And then we can also always point to the next one, whatever. Do people really backseat programming? Some do, yes. Although I didn't have it in a while. But yeah, maybe that tag is a bit overly defensive. I don't know. But like in the very beginning, like from last year, there was one person that was really trying to drive more or less. Yeah, basically like that. I wonder if this needs to be doubly linked lists. Do I ever need to go from one bank to the other? Probably not. I always need to just need the first one. Yeah, that's fine. That is fine. Okay, so, and then here we can just simply say, um, I mean, this doesn't necessarily need to be a pointer, but I can do it as a pointer. What actually is a Game Boy assembler? So it basically is a way to write games for the Game Boy, right? Or a ROM file essentially, so you can use it in an emulator, and it's basically translating assembly language into machine instructions, right? So you have like instructions like LD for loading stuff into certain registers of the Game Boy, or like math operations or whatever, and then of course like all your tile data and all this kind of stuff. It's a very crude programming language, let's put it this way, right? It's just one way you have to think about like your memory layout. And no, it's not really a game engine. I'm just writing the code that takes this assembly language and creates the ROM file out of it, right? Or a game engine for ROM. Nah, the analogy doesn't really fit. Yeah, I think that's... Yeah, exactly. So like here, for example, the program GBasm is like a Hello World application, right? Where it waits for the V blank of the Game Boy, then copies tile data into memory, and then copies the tile map into memory, right? And then you have basically this is the tile data, so this is the actual tiles that you can have, and then you have the tile map, which basically indexes into these tiles, and then it kind of forms an image out of that. Actually, I can quickly run this Hello World thing, because I already had a working assembler, but that was done with Visual Studio and the C runtime libraries and all this kind of stuff, and I wanted to remove all of that because, I want to do everything myself, and also wanted to learn some stuff. Anyways, hang on, where do I have it? I think here, Micro, Sublime, Game Boy. There we go. So this one is actually the Hello World assembly, and I created this Game Boy ROM out of it. And if you just start it, there you go. This is what it spits out. Yeah, I mean, to be fair, I got this Hello World from someone else who did it, right? I didn't write the assembly code myself. I want to learn how to write the assembly code, but I also want to learn how to program development tools, because I use them on a daily basis, but I have no idea how they really work, right? So that's why I set out to write the assembler and then use that assembler to learn assembly for the Game Boy to write like Game Boy games and stuff like that. Anyways, that's the idea. And yeah, I had a working version already, which was my first attempt, and it's horrible code. It's like all over the place, and it's not really nicely structured or anything. So I thought I'd give this another shot without Visual Studio and anything, and without the C runtime libraries, and just do it like this. If it works, is it really horrible? Yeah. I mean, let's put it this way. After I wrote it, I learned a lot more about C and how to use C nicely. And then I kind of got the urge to rewrite it. And yeah. What editor is this? This is Sublime Text. Yeah. It's just what I'm used to. So that's why I'm using it. I wouldn't say it's necessarily the best editor for C programming or whatever, but hey, it works for me. So. Okay. I mean, I haven't set up anything, right? I literally just have my whole folder in here and then just use it with C syntax highlighting. That's it. I don't even use the internal build stuff that they have. For that, I have my own build bat file that I'm using, right? So I can do build stuff like this. Okay, apparently I have an error. Oh, right. Let's put it in comments. So there you go. Right, I should actually finish these functions. Get memory arena struct undefined. What do you mean? Did I forget the name again? Oh, it's get memory arena type. Okay, fine. Fine. What? Did I not save? What are you doing? Oh, there we go. I didn't actually change it. There we go. Don't worry. I mean, questions are welcome. I like some distractions. It's fine. Maybe I should remove the no backseating tag so people don't feel discouraged to actually chat. Yes, we're going out soon. Oh, you want to say hi? No, you run away. Okay. Come here. Sorry, I have a tiny dog down here. And she's starving for attention. Okay, anyways, let's get this output binary at least done. So we have the output binary, and then we want the first section, right? Actually, we want 2 sections already. So let's just allocate 2 sections. So for that, we say... actually, I do not have a macro for this, I realized. So have to do it the old school way with get memory arena buffer. Right? Right. Void star buffer, get memory arena buffer in this arena, and we want size of binary section times 2, right? And if I mean, I do not do null checks at the moment. Maybe I should do that. Let's put a big fat to do in here. To do check for null allocations. So, and then we have binary section numero uno. That's gonna be bank 0, right? Which is just the buffer. And then we have binary section numero 2, that is bank 1, and that is also gonna be a binary section, but this one is gonna be on buffer plus size of binary section, right? So, and then we have bank 0. Do I think I will be able to finish before the Game Boy becomes a game man? I mean, that ship has already been sailed, hasn't it? How old is the Game Boy? It's probably a game granddad by now. No, probably not. Actually, the Game Boy is as old as me. What am I talking about? Oh dear Lord, I'm old. Okay. Oh, I mean, these are fixed sizes, right? So really, I don't... you know what? Times 2 plus 32 kilobytes, right? Let's just get those out of the way. And then what we'll do is have this, and then let me close this file. Actually, let me just at least copy these before I struggle again and forget. So bank 0 base would be actually just bank 0 plus 1, right? Then bank 0 size would be 16 kilobytes, and the position would be 0 because there's nothing in that ROM yet. Okay, then we have bank 1, and bank 1 would be buffer plus size of binary section T plus kib 16, right? Bank 1, actually, bank 0 first is, well, myself. Okay. Bank 1 base. That one would be bank 1 plus 1. Then bank 1 size is 16 kilobytes. And then bank 1 position, also 0. Bank 1 first is bank 0. And bank 1 next is 0. And then we have bank 0 next is bank 1. And then we have result. Actually, I wonder if I even need to point to the first element. Let's remove it for now and just have next in there, right? Yeah. Okay, brain. Just bank, result bank. Okay. Bank equals bank 0. I like that better. Bank 0 base, and then just add the 16 kilobits to it. Actually, even better, bank 0 size, right? That should be correct. I want to call that first. Because we also need to point to the current bank, right? So we can switch sections throughout the assembly file, and we need to figure out which bank we are currently in when we're trying to write into the output ROM, right? So that's why we have the current. So that should be result current equals also bank 0. Yeah. And I mean, technically for for bank 0, the position is not entirely correct, right? Because the first position we can actually write to is 150 in hex. Because this is after the Game Boy header. Because the Game Boy has a header from hex 100 to hex 150. If you want to figure out stuff about the Game Boy header, I released a YouTube video on that if you want to watch it. And then everything before from 0 to, hex, hex 4F, right? From 0 to FF is another section of code, but this is like split up in 8-byte long sections that handle interrupts. So all the interrupt handling is there. Interrupt handling, right? And that is, again, split up in like 8-byte sections. So you have from 0 to 8, right? No, sorry, 7. Would be, I don't know what the first interrupt is, right? I probably have a text document somewhere on this. Oh, there we go. So you have reset 0, reset 1, 2, 3, 4, 5 to 7. Then you have v-blank interrupt, right? So those are custom resets that you can specify on what to do, so you can quickly jump into it. There's like a very short instructions to jump into these addresses. Then you have a status interrupt, timer interrupt, serial port interrupts, and then the joypad handling. And the joypad handling is like slightly bigger than all of these other ones because it goes all the way to the header. Yeah. I don't know what I did here, but okay. I guess it was a showcase or something. Oh, I already thought about the section stuff here. Should have just looked at my old notes. Oh my god. Right, and those are RAM addresses. Those are all the instructions. Okay. Okay, maybe let's just start at position 150. Why not? I mean, yeah. Okay, so this will create our output binary, which we then can write into a file. I'm not going to worry about the file writing right now. We can just check the stuff in the debugger if writing is correct. And basically what we want in the parser, when we have, let's say, case keyword type nop, right? We then basically want to say write the instruction for no op into the current bank that you're in on the current position that you're at, right? So we probably want something like write something like this. I'm not going to do error checking at the moment, but, you know, I really need to think a bit more about the error checking, but I can have a quick assert at least here that binary is not 0, right? So we can at least do that. So basically what we want is result current, right? We want to get the current bank. Binary section T. And then we want to write on bank position the following byte. And we can increment position afterwards. I mean, you know, probably wouldn't want to do it this way because if the position is at the end of the bank, we can then think about what to do. Do we just switch to the next bank and just write stuff into that? I mean, that would probably be nice, to be honest. So you don't need to worry about the sections. You don't need to write out the sections. It just happens automatically. That might not be a bad idea, to be honest. But then, of course, you have some more complex instructions, right? You're not going to just write 1 byte all the time. Sometimes you just want to write, you know, multiple bytes, like 3 bytes or whatever. So you need to make sure that all those 3 bytes actually switch in one bank. They should not overlap a bank. Unless it's bank 0 to bank 1 on a 32 kilobyte ROM, but I'm not sure how to handle that yet. So we'll see. But basically, this is just the simplest form of writing into a bank, right? And then you can say, you know what? Let's implement all the single byte instructions there are. There's a few of those, like these. Yeah. So go to our definitions file here and just damn, can't do that. Do just this. Oh, I could have done it. Never mind. So DAA, CPL, right? NOP, CCF, SCF, DI, EI, HALT, RT, RLCA, RLA, RRCA, RRA, and stop. Probably should remove them down here, but whatever. I'm not going to worry about that right now. But essentially, these are the keywords that we're going to support for now, because they just need to write a single byte, right? So let's plunk them in here. And that, what did I just press? Okay, and we want to call output binary add byte. We're gonna have the output file, and then whatever the code is, you know, that we need to add for that particular instruction. Now I have them right here, so DA would be hex this, hex this, that is 0, 0, okay, 3F, 37, F3, FB, 76, D9, 0717, 0F, 1F10. Okay, and that's essentially it. Right now it is not. That is a bug. Break. Because switch statements fall through. All right, so these instructions are just single byte instructions. Those should just simply work, but now we need to kind of figure out where to get the output file from, right? So maybe we just... Okay, we can be cheeky and just attach it to the tokenizer, because the tokenizer already has the source file attached to it, so might as well, right? So let's just go and say... output binary T. Let's just call it ROM. Why not? What? What did I change? Oh, and this needs the byte. Okay, tokenizer, new tokenizer now also needs to take the output binary T, right? And then we can just say results ROM equals ROM. And then probably also say ROM is not 0. So this... busted. Okay. Tokenizer ROM. And here, output binary T, output, whatever, what did I call it? Oh, just output binary. Okay. What? No. Why did I name this result? Copy paste, yay! Okay, so this gets us the bank, and then we adjust the position. Yeah, okay. Okay. Declared formal parameter list different from definition. What do you mean? Oh, right. I see what you mean. You mean this one. Okay, there you go. Builds, let's say, run debug. Actually, to make sure this actually worked, right? Let's just plonk them in here. Boop. Oh no, there was a method to like... Yeah, there we go. What? Run debug. There we go. Okay, but I don't want to jump in immediately. I actually have to adjust this one. And then I can run it. Okay. So after parse source file, let's just check the output, right? Bam. So output is right here. Arena is 0. Did I not assign the arena? Did I not? Did I not? Did I not? Did I not? I thought I did. Why didn't I? Sacre bleu. Arena equals arena. I mean, luckily we don't use it anywhere, but hey. Okay. Okay, so we have written some stuff. We went from hex 150 to 15E, right? So we can now actually check whether the output is correct. We can do this by looking at watch. And we want output. Yeah, what are you doing? Oh, God. I want this one. Okay. Output first base, right? And we want this as an array of output first size. Bam. Okay, and then we go to shoot here. So that's the data we have written. We can actually say hex, right? Actually, can I say this for all of them without having to like... Oh dear. No? Can I say comma hex? No. Oh, that's a bit annoying. Oh my... I mean, the hex numbers are right next to it. What am I doing here? It's all right. Okay, so 2, 7. I mean, we put them in the same order as we like parse them, so you can just check. 2, 7, 2F, yay. 0, 3F, yay. 3, 7, F3, FB. 3, 7, F0, F3, FB. 7, 6, D9, 0, 7. 7, 6, D9, 7. Yep. 17, 0, F. Yep. And then 1, F10. Okay, there you go. And now we just have to do this for all the others. Okay, but in all seriousness, I'm not going to keep it like this, right? Because this would directly be taking the tokens and immediately starting parsing. This is not what I want. This is exactly the same mess as I had before, right? Which ended up in a lot of messy parsing code of like 2,000 lines here. And It was horrible, 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 horrible. Instead, what I would like to do is build basically kind of like a syntax tree out of these tokens, right? So instead of like going token by token and saying, oh, this is token keyword so and then just write this output byte, really what I want is something that says, all right, so we have an operation, right? The operation is keyword and then whatever the keyword is, you know. And then it has operands, right? An operand count, and then what are the operands, right? You can probably have a linked list as well, where you just say next and stuff like that. So this is just to validate whether the whole line of code is correct, because you can have like either just LD, so you just have an operation with a keyword and 0 operands, right? So you can immediately say if there's an operand, for example, if we have a NOP instruction and it has an operand, we know it should not have any operands. So if we get a count that is bigger than 0, we can already say, hey, NOP does not take any operands. What the hell are you doing, right? Remove those. Anything after this is nonsense. So we can print out an error for that. And the other thing we can then do is, once you have operands, right, or you have an instruction that actually takes operands, we can then just validate the operands one by one to check whether those are correct. And then something that my old assembler did not support, but which I want to support in this one, is things like here. So here, I have this hex value right here that basically is the count of bytes down here. So, and at the moment it's quite annoying because you would have to look and exactly know how many bytes you write and then supply the value. But we have a start label and an end label here. So why not just say this, right? Let me... Whoops, unable to save. All right, oh. Is the debugger still running? Yeah, that's why. There we go. Right, so why not just say label end right here, which is tiles end. So this will have the position after it has written all the bytes to the output. You know kind of where you are on what address this is, right? So you can just take the end address, subtract it from the starting address, and you have the amount of tiles you actually want to use. So you have a value right here. So I basically want to support basic arithmetic operations as well. So we could also do plus or divided or times, right? And then obviously you can chain them like however you want, right? Pretend those are labels. And I don't want to deal with like resolving them as I go along with the tokens, you know, that would be quite insane. So you rather just want to build like a basic structure that's easier to go through, like an abstract syntax tree sort of thing, although not quite. I just hate that name, to be honest. It's just, yeah, whatever. The only thing that doesn't need to work with this sort of operation thing is like the labels, because those always are like prefixed. They always go in the beginning. So this can still be the same, right? Doesn't matter. But as soon as we get to a keyword or a token type identifier, or we do, I don't know, token type directive, right? So with any of these token types, we actually want to build some kind of tree, right? So tree equals build tree tokenizer. And then what you want to do is just say parse tree, and that will then actually do the parsing and check whether the syntax is correct or not, and write stuff out into the output file. But I have been streaming for over 4 hours now, and I need a coffee, I need food, and I need to take my dog out for a walk. So I'm going to stop this here. Since this is kind of a milestone... thanks for the follow. I'm going to... Yeah, I mean, it's kind of a milestone, right? So it actually works. Well, except I have added stuff in my... What? No, what did I do? Did I not reset the parser properly? Come on. Oh, right. So it can actually do stuff. It doesn't output anything yet, but it at least recognizes some of the keywords. And then for others, it would report an unsupported instruction if we had actually finished the definition file, which I might actually do. I would like to clean up like small things. I'm probably going to do that not on stream because it's tedious and boring, and it's really just like dealing with like error handling stuff, and then bundle this up as Alpha 4 and put it on my Ko-fi page. So if you want to get the source code so far for this, I'm going to put that up. And then next time on Monday, which is the next scheduled stream, I will be basically doing Alpha 5, and this is where we will build the syntax tree and yeah, try to get that going. That's about it. Are there any questions so far? I'll give a few minutes just for questions. Right. Honestly, let's just implement them all. Right. Ink day. Oh, hang on. I can just be nifty about this, can't I? Can just do this, and then I can say doodleroo. Convert the case to lowercase. No, I can't. Oh, hang on, does that work? If I do it this way. Ha! Saving some typing here. Okay, so now if I build and run this, did I take knob out of there? Apparently I did. There we go. So the keywords are now all in there, but then it basically just says unsupported instruction LD, CP, and all the instructions that I used in the Hello World application. But anyways. Okay, so there seem to be no questions, so I'm just going to end it now. End the stream, that is. That sounded weird out of context. Anyways. Okay, thanks for watching. Bye.